Hi, welcome back. So this is the part 2 of the trigonometric ratios calculating unknown something, and last time was sides, this time it's angles. Just quickly, don't forget to set your calculator to degrees and not radians. How do you do that? Click on the mode and set to degrees, DEG. So our calculator looked like this. So for our one, it was, turning it on. And then to make sure that it was in degrees, look for the little D. And then if it wasn't, then shift setup and then look for degrees. So over there, number 3, click on 3 and it would change it to D. So today we're going to look at the inverse. Do you remember the word inverse? It meant, well, for this one, the inverse of dividing by 5, it was times 5. The inverse of timesing by 2 was dividing by 2. The inverse of -1 was +1. And the inverse of plus something, like +3, was -3. So they undo. Now we can use the inverse to solve for x. Let's do that with sine cos tan. Let's say we had sine 30 is equal to 0.5. Now if I gave you sine x is equal to 0.5, then you would assume that you could work out x to be 30. But how do we get from this to x equals 30? Well, we need to get x by itself, so we need to get rid of the sine. If I sine inverse sine x, that cancels out. So now we have x equals sine inverse 0.5. So let's plug in sine inverse 0.5 on our calculator. So turn it on. And then sine inverse is down here. See that little yellow one? So to get to the yellow one, we're going to click shift sine. So that gives us sine inverse. And then our question is 0.5. And it gives us the angle of 30 degrees, what we expected. So whenever you sine inverse the number or the ratio of the sides, you're going to get an angle. So sine inverse gives you the angle. Remember that. Let's try these on the calculator. Now we know that we can plug this in to get those. So if I sine inverse those numbers, I'm going to get back the angle. So we can try that on the calculator. Let's try that on the calculator. So sine inverse of the number 0.4226 will give us the angle. So cos inverse of the number there, cos inverse of 0.9063 is going to give us the angle 25 degrees. So we can continue pressing that, and inverse tan again is shift tan. Now the reason I'm putting this side by side is so that you can get used to seeing that sine inverse, cos inverse, tan inverse. The answer is going to give you an angle. So sine inverse a number gives you an angle. Now sine inverse 0.5 and cos inverse 0.5 are going to give you complementary angles, and tan inverse 1 is 45. So recap, the way we read it is the inverse sine of, the inverse cosine of, and the inverse tangent of. Let's practice this. So sine theta equals 0.65. What is theta? What is the angle? Let me grab my calculator, 0. So now for the sine, we're going to inverse sine 0.65 to give us 41 degrees. So 40.54. So it's going to be rounded up to 41. So the next one, cos theta is 0.65. So inverse cos of 0.65 is going to give us the angle, which is 49 degrees. And the last one, inverse tan 1.75 equal. It's going to give us the angle of 60 degrees. So theta there is 60 degrees. Now that we've practiced finding theta with a calculator, let's have a look at a triangle problem. Find the size of the angle correct to the nearest degree. So we have to find theta. Step number 1, like before, label. So we have H, that's next to A, and opposite. Step number 2, think SOHCAHTOA. We have A and O, or O and A, so it's TOA. So we're using tan. So tan theta is equal to O over A. 11. And to get rid of tan from the theta, to get theta by itself, we inverse tan on the other side. So plug that into the calculator, we get 24 degrees. If you're wondering how to plug that in the calculator, you would type in inverse tan, and for the fraction 5/11 and equal, and round it to the nearest degree, 24 degrees. Next question, find the size of the angle x correct to the nearest degree. So sometimes we use theta, sometimes we use x. Pause the video and try yourself, and then unpause to check your answers. So here we have label H, A, and O. And then step number 2, so katoa, we can see it's O and H, or in other words, so. So now we have sine x is equal to O over H, O, so 3/9. To get rid of sine, we have to sine inverse the other side, and then sine inverse a third is equal to 19 degrees. I hope you got that. If not, try it again and make sure you spot where your mistake is. Little bit trickier question. Cooper placed a 1.2 meter long ladder 0.5 meters from the wall. What is the magnitude of the angle that the ladder makes with the ground? So the angle that the ladder makes with the ground. So let's draw this. We have a wall, we have a bit of grass with the ground. Now we put the ladder. What does it say? 1.2 meter long ladder. So the ladder itself is 1.2, 0.5 meters from the wall. So it's here from the wall. So it's this bottom distance here, not the wall, from the wall. Put that in, and then we can see there's a right angle triangle. So we're going to draw that. And we'll pick this angle over here because it says angle the ladder makes with the ground. So ladder is here, ground here, so it's that angle. If they wanted the other angle, it would read the angle the ladder makes with the wall. Okay, with the wall, with the ground. Be very careful which one it is. Okay, now we do the same thing as before. Pause the video, continue when you're done. All right, step number 1, label H, A, and O. And then we realize it's okay, we just need A and H, which is cos. So we're going to use cos. Cos of the angle is equal to A, 0.5 over 1.2. How do you get theta by itself? Undo the cos by finding cos inverse of that ratio. Plug that into your calculator, you should get 65 degrees. So the ladder makes an angle of 65 degrees with the ground. It is very important you put that statement in. So to recap, draw a diagram. You don't have to draw everything, just a triangle. Step 2, read and label carefully. Remember, it's that bottom angle, not the top angle. The top angle would be ladder against the wall. And then HAO, put that in. Then SOHCAHTOA. And lastly, solve and write the sentence for your answer. Okay, that's it from me today. Practice, practice, practice. If it's new to you, it might be a little bit tricky. Thanks for watching, and I'll see you in the next video.